All right, I'm going to go ahead and get started. First of all, thank you to everyone for hanging out for the last session of the day. My name is Jeff Mielef, and I'm a Principal Program Manager in the Office 365 team. And we're going to be talking about cloud network planning and troubleshooting today. Hopefully you're all here to actually be here for this session. We kind of moved it at the last minute, which is great because the original room that it was in I don't think would have held all of you. I assume that's why we made the switch. Looked like the other room had space for about 20 people. Just a quick little bit of introduction for myself, and then we'll dig into the content. I am a longtime Microsoft employee. I've been at the company for about 17 years. And in my current role, I work in the Office 365 customer experience team, specifically on the Fast Track team that focuses on deployment and architecture for Office 365 customers really of all sizes, but the vast majority of issues that I deal with tend to be more around the enterprise space, very large organizations. And I deal with a sort of a broad set of escalations that come into my team around both major problems that have occurred. So if you have a problem with Office 365 and your CEO picks up the phone and calls Satya Nadella and starts yelling at him, there's a very good chance that you're going to end up on the phone with me at some point. And I also deal with issues primarily around identity and cloud networking that are sort of more run state issues. So customers who are interested in deploying and talking to them and making sure that the right things are being done, the right architecture choices are being made, so that you'll have a successful experience with our products. And that's why I'm here today. And actually, as I mentioned in the previous session that I did earlier this afternoon, I love coming to events like this because it means, in general, I get to talk to happy customers as opposed to the ones that yell at me. So hopefully you're all happy today and you won't be yelling at me. If you do have questions as we go through the content today, feel free to raise your hand. You may have to raise it really high and swing it around because I have some very bright lights in my face for the video recording today. But I am happy to take questions where I can. And if we can't get to everything, come let me buy you a drink at the Ask the Experts session, which is actually right after this in Hall D1. So let's start off by talking about some common problems that people run into around cloud connectivity and performance. And then we'll drive into some best practices to try and avoid some of these problems. So common reasons that we see that result in bad experiences with Office 365 typically include things like poor connectivity to our network. I mean, that's fairly straightforward. If you have poor connectivity to Microsoft's network, you're not going to have a great experience accessing data and applications that live on our network. Same thing would be true for your on-premises system. If you were deploying things and exposing your managed services to the internet, if your internet connectivity is bad, your users are not going to be happy. Latency is also a huge problem. There's a lot of magic that we can do in software to try and overcome latency issues. Outlook cached mode is a great example of some magic that we can do in software to try and avoid issues around latency. But at the end of the day, there are always going to be challenges associated with accessing applications remotely if you have significant latency between your user and where those applications or the data used within those applications is hosted. You know, we start talking about physics problems at that point, and there's only so much we can do with software to solve physics problems. We also see a lot of issues around egress configuration. What I mean there is where you're connecting to Microsoft's network. How many of you work for organizations that have multiple locations? Okay. We're going to be talking quite a bit about egress configuration, and that's going to be very applicable to you in terms of how you route traffic between those locations and where you are going to peer with Microsoft's network. In other words, where that traffic is going to connect into Microsoft from those different locations for an optimal configuration. Bandwidth, another huge problem, or huge potential problem area. Moving to software as a service requires that you think about internet bandwidth or dedicated bandwidth to Microsoft a little bit differently than you may have in the past. If you've sized your internet connectivity for your organization with the idea of inbound and outbound SMTP, maybe some external publishing of Exchange or SharePoint for users that are mobile, with mobile devices or working from home, maybe the occasional VPN use. And now you look at moving to Office 365 and using that same infrastructure to allow your users to access services that you had internal historically, or had deployed internally historically. You may need to do some serious planning around bandwidth utilization for that internet connectivity. It's a very common mistake. People make assumptions that, even though they're using 50% of their internet connectivity bandwidth today, that they'll be fine moving to Office 365. It's not necessarily true that whatever buffer you've allocated will be enough to actually support your users. And then we also see issues with client misconfiguration. We'll talk a little bit about that, both in terms of settings within applications that are used to access services within Office 365, but also operating system configuration, network driver configuration. There's lots of different places that mistakes can be made that will result in really painful performance problems when using Office 365. So before we go into some detail around all of these topics, I want to spend a few minutes talking about, at a high level, what we're trying to build and how we're building it, because that will help to explain some of the decisions that we've made and some of the choices that you have to make around how you actually connect to Microsoft. So in general, we make an assumption that the services that we're building for Office 365 are going to be accessed over the internet. We do have alternatives for that we'll talk about a little bit. But in general, we're assuming most of that access is going to come across the internet. And we want to provide a fantastic experience with those applications that we're building, regardless of where the data associated with your tenant actually exists. So how many of you are from outside of the US and traveled to the US for this conference? Anybody from Canada? No. OK. So I can skip over the comments about Office 365 in Canada in a few slides. That's good to know. In general, connectivity in the US is fantastic. A little bit different than some of the other places that I go and talk to customers. I was in the Middle East in December and doing some trace routes there as part of some of the demonstrations that I typically do. Got some very different results from what we'll see when I do those demonstrations here. So connectivity is great, but what we consider our North America region for Office 365, which is essentially the US and Canada today, we don't have data centers in Mexico. When you think about that region, it's actually extremely large geographically. And when you create an Office 365 tenant, we'll just talk about Exchange Online here for a moment, we're going to spread out the mailbox servers that are responsible for your Exchange data across that region. And at any given moment in time, there may be 4 different data centers spread out across the US that are actually providing service to your users in terms of where that data is located. What we want to do is make sure that that doesn't matter. So from a network connectivity perspective, we do a lot of work to ensure that those data centers are well connected to each other and to you. The best possible job that we can do. Let's talk about how we do that. So in terms of Microsoft's data center infrastructure, I suspect you probably know something about our data center infrastructure. We typically show some videos and keynotes that show lots and lots of servers and racks and really cool pictures of cooling equipment and diesel generators and things. In general, we spend a huge amount of money on data center infrastructure as part of growing our cloud business, both Azure, Office 365, the other cloud services that we're offering. We have over 100 data centers worldwide that include, so that includes data centers as well as facilities where we have network edge components. So not necessarily data centers with servers that contain customer data, but physical locations where our network has a presence or where we are storing data. We spend a lot on compliance ensuring that we're doing the right things to ensure that you can trust us with your data and with the network traffic that's entering our network. And I'm not going to go into much more detail on this. We have lots of content out there around our data center infrastructure and trust components. We have multiple global regions. If you're in the US and you create a tenant in Office 365 with a billing address that's a US address, then your tenant is going to be created in the North America region. And that has some implications in terms of where that data is going to be stored. The same would be true if you were outside of the US and you created a tenant in the United Kingdom. We would make assumptions based on that billing address in terms of where that data gets located. We have a couple of sovereign regions, actually 3 that we've announced, 2 that are live today. Anyone here worked for the US government? Okay, so we have a US government sovereign region that's essentially an isolated, self-contained version of Office 365, and we have one of those for China as well. We've announced one in Germany that has not yet launched, but will be available soon. We provide quite a bit of data about customer data at rest, and so we actually show you where the physical data centers are that could contain your data. We don't tell you that at any given moment in time, the active copy of your data is in, insert city name here. But if you go to the URL that's up there on this slide, you can actually see a map. You select the region that you're in. You'd select North America. And this will actually show you an image of, or a map of the North America region, and specifically where the data centers are that will contain your data for Exchange, SharePoint, and Skype, customer data at rest. So in terms of, I'm actually going to skip forward a little bit here. So in terms of data centers in the US, these locations are the primary locations where we store data today, and where we have our major connectivity interchanges. We have data centers in Quebec and Toronto for Canada, but since we're not from Canada, I'm not going to go into that. And I will just keep pushing forward here. All right, so Office 365 in the US. So if you create your tenant and specify that you have a US billing address, we make some commitments around in-country data residency. Essentially what we're saying here is even though within the North America region we do actually have data centers in Canada, we are making a commitment that we're going to store your data at rest in data centers in the US. We make the same commitment in Canada for tenants that were created after we launched those Canadian data centers, or tenants that opt in to have their data moved, that will store that in Canada. This is not a guarantee about data in transit. We'll just call that out. It is a guarantee about data at rest. So be aware of that. I'll skip over Canada. So talked about data at rest. Let's talk about network infrastructure, because that's a little more relevant to today's session. So Microsoft's global network is a pretty massive feat of engineering. Microsoft's global network should not be confused with the internet, though when we look at maps of it and the level of connectivity around it, it might seem sort of like the internet. This map actually shows the major locations where we have Microsoft network equipment and the connectivity in between those locations. And noticed a couple people taking pictures of the slides. I'm 100% sure you're going to get access to the slides, as well as a full video recording of today's session. So don't worry about doing that, unless you want to. I'm totally cool if you want to. So our network has actually been recognized as one of the top 3 networks in the world, both in terms of the amount of bandwidth that we have within our network, as well as the connectivity locations where you can peer with our network. You can imagine who those other 2 might potentially be. I'm not going to name any competitors' names here, but folks who are in the same business that we are, providing infrastructure services to everyone in the world, tend to have networks of this size and magnitude. It's actually kind of fascinating to think about where we were a decade ago and look at the size of the network links that we're deploying today, where we're not talking about megabits. 20 years ago when you were deploying T1 lines, you were looking at 1.5 megabits for wide area network links. We're not talking about gigabits. We're actually talking about terabits of bandwidth now between our network locations. And when you think about why we're allocating amounts of bandwidth like that, it's for many reasons, one of which is obviously we want to make sure that we have the right level of resource allocation to be able to meet your needs for inbound requests from your end users hitting those services that you're paying for. But we also have our own internal needs. You think about, I mentioned with Exchange Online, we might be serving your requests from up to four different locations simultaneously. Well, we're actually storing 4 copies of your data in those 4 locations, and we're constantly replicating that data between all those locations. Additionally, we occasionally have the need to, say, get out of a data center. It might be a leased facility in some part of the world. All of a sudden, we decide that, we want to build our own. We actually have to make sure that we have enough network bandwidth behind the scenes that we can actually move everybody's mailboxes in that entire data center to a new location. We have done this, and we do this. I won't say on a regular basis in that particular scenario. That's not a regular thing, but it happens, and we have to support that. So we have a massive investment in this infrastructure. We pair with over 2,000 ISPs globally, and that number continues to grow. And if you do some trace routes actually into our network, and I'll give you an example of how to do this in a few minutes, you can actually kind of start to see some of that network infrastructure. The DNS names of many of our routers is associated with airport names or other abbreviations that are fairly obvious. So you can start to get a sense of where we are from a network perspective and how traffic routes through our network. If there's one thing that you take away today from this session, it's that from an Office 365 perspective, we believe very strongly in something that we call hot potato routing. And what that means is that we very strongly believe that for the best possible end user experience with our services, we want you to get your traffic onto our network as quickly as possible. That's not to say that we don't trust internet service providers to route traffic appropriately, but from an incentives perspective, we are very incented to make sure you have the best end user experience with our applications and services. It's not necessarily true of everyone else that you might send your traffic through. So when you think about different choices that you can make about how to route your traffic, how to peer with Microsoft, particularly if you have multiple locations, getting your traffic onto our network as quickly as possible should always be the goal. So that's the one most important thing I want you to take away today. We'll talk a little bit about how to do that in a few minutes, but I want to make sure you heard that up front. This is a list that one of my colleagues dumped out of all the different major peering locations where we peer with ISPs today. And this is actually accessible to anyone if you want to go take a look. Anyone here actually ever looked at peeringdb.org? 1, 2, okay. For the true internet networking geeks in the room, you'll be familiar with this, but it's a public database of ISPs, network service providers, folks who build what I've been describing in terms of Microsoft's network that will actually show you both public and private peering locations that a given network is connected to. And networks on the internet are associated with what are called autonomous system numbers. Microsoft's number is 8075. The Microsoft Global Network is AS8075. So if you go to peering.org and search for AS8075, you'll get the entry for Microsoft's network, and you can actually scroll through and see all the locations and all the different ISPs that we pair with, and get a sense of whether or not the ISP that you're using or the interconnection points where your network equipment lives are optimal for connectivity to Microsoft. And if not, what some of your options might be if you wanted to try and improve that. So a key task around trying to make sure that you're getting onto Microsoft's network as quickly as possible is performing a little bit of a network assessment with Traceroute. Everyone here familiar with the traceroute tool, I hope? Yeah, most of you? Okay. For those of you that aren't, go do a Bing search for traceroute. Very useful tool. It'll essentially show you the path that your packets are taking through through routers to get to the intended destination and the latency associated with each step in that path. Very, very useful tool for troubleshooting. So one of my colleagues on my team put this together. It's 3 different examples, essentially going to the same location. It's actually going to, the target is his personal SharePoint site in Office 365. He happens to live in London, or just outside of London, and as a result, his SharePoint service is hosted in one of 2 locations. We do failovers. It's either in one of our Dublin data centers or in one of our Amsterdam data centers. And so the trace routes that I'll show you here are either directed towards Dublin or Amsterdam. You'll actually see in this particular example, DB3 here, that's Dublin 3. And that's the point at which the traffic is hitting the last data center, and then this is likely the load balancer sitting in front of the server that he's actually using. But key point here, so this is taken from a machine in the United Kingdom. It's peering onto Microsoft's network in London, and it's getting there in somewhere between 26 and 35 milliseconds. That's pretty good. Same thing done from a location in France. I think he was presenting at a conference like this in Paris. And in this particular case, peering with Microsoft's network in Paris in 8 milliseconds. Can't complain about that. That's great connectivity. Similar thing in Florida. I believe this was when he was in Miami for the same, I think we called it the Cloud Roadshow then, but essentially the same event. Peering in Miami in 24 milliseconds. Not quite as good as the Paris example, but still not bad. Certainly would provide some great experience. You'll notice from Miami, we're then crossing the network. Once we hit New York City there, we're going over to London, and then on to Dublin. Now this one's interesting. This was taken from Scotland. And you'll notice that there's a problem here. Now, we've hidden the names, or a particular name, because we didn't really want to call somebody out in a public session like this, particularly since we're being recorded. So we're going from a desktop in Scotland, and we're attempting to access a SharePoint site that's actually active in Amsterdam. I know that because of the AMS and the last entry down there at the end. So we go from London to New York. Still over that ISP's, whatever the ISP is that we're connected to, where the desktop exists. And so we go over to New York, and then we actually peer with Microsoft's network in New York. And then we come back across the ocean and get to Amsterdam eventually. That's really bad. So if you see something like this that makes absolutely no sense geographically, and we do see this more often than you would think, it's actually possible to create routing configurations that take multiple hops across oceans, more than 2. It's possible to create interesting routing configurations that go around the world, potentially more than once. That's a good opportunity to have a conversation with your internal network team as well as your internet service provider about how things could potentially be optimized. Sometimes this is the result of architectural choices made by a customer, more often than not when ExpressRoute is in play. Talk about that in a few minutes. But I would say more often tends to be a problem at the ISP level. And it can usually pretty quickly be corrected with a discussion with the ISP. So this is a very good thing to take a look at. It takes about 10 seconds to do and gives you a great idea of how you're connected. So just as an example, I always like to take a quick look at what things look like from here. So I'm actually going to do a trace route to my personal SharePoint site from our location here. I did this earlier, actually both from the demo podium here, connected over Ethernet as well as over Wi-Fi from the speaker room. we found that things are actually pretty well connected here. So we're all in the 1 millisecond range, and we're already on Microsoft's network in Chicago, right there, still with 1 millisecond latency. Fiber is wonderful, isn't it? And so once we go there, we're actually at this point, you could sort of think of this as MPLS. We're starting to go elsewhere in the country, and we end up in BN3, which is one of our data centers in Virginia, where the active server for my SharePoint site is hosted. But the fact that we're actually peering with Microsoft's network in 1 millisecond is awesome. There are a few locations outside of the US where we see that kind of connectivity. There are a few, but not many. So hopefully you have a similar experience. All right, let's jump back in here. So you have a few different options when you think about connecting your corporate network infrastructure to Microsoft's network infrastructure. There's really two primary options that you need to think about, whether you're going to use proxies or direct routing. We'll talk about pros and cons of both. In general, we like direct routing better. I'll explain why. But we also understand that proxies are a necessity of life for many of you. How many of you have a business requirement, either inflicted on you by your security people or risk management people, or you actually have potentially a very legitimate technical reason from a routing perspective to have all internet traffic egress through a proxy today? Oh, come on, there's got to be more of you. Really? Okay. That's fantastic. It's typically a larger number than that. So you might be tired. We'll see. Tired of not raising your hands. I don't know. We'll get into ExpressRoute in a little more detail, but I do want to call out here that if you do choose the ExpressRoute method of connecting to, actually, I haven't even explained what ExpressRoute is. Does everyone here know what ExpressRoute is? Yeah, a few. Okay, most of you. That's good. ExpressRoute is our dedicated connectivity option for both Azure as well as Office 365. Essentially, all the cloud services that Microsoft provides. It's think of it as a dedicated circuit of some type that peers with Microsoft's network. It is not a dedicated circuit into a Microsoft data center where your data lives. So just to make sure you understand that. Many people have that misconception that, oh, my data is in the BN3 data center, so if I buy ExpressRoute, I'm going to buy it between my data center or my corporate network and the BN3 data center. That's not what ExpressRoute is. It's a direct path between your network and Microsoft's network. Important to call out for Office 365 that if you do use ExpressRoute, if you choose to go down that path, we do still require internet connectivity for Office 365 to work properly. There are some things that still utilize the internet. So visually, how does this look? If we use the proxy method, which is the top connection method there, you've got your internal LAN, potentially a wide area network, or certainly a wide area network for those of you that have multiple locations, and you have a proxy somewhere around your internet egress, where all that traffic is being examined and proxied out to the internet. With the direct method, slightly different type of device or devices that are managing that traffic. And instead of proxying, instead of terminating the session at a proxy, where you can do all kinds of good and potentially bad things with it, you're just going through a NAT and PAT device where you're doing a little bit of manipulation with network addresses, and the traffic itself just continues to flow out to the internet. You can still block things with devices at that point, but you're not actually terminating connections and reestablishing new connections as you would with a proxy. And then with the ExpressRoute option, what you're doing there is defining a connection between your LAN or WAN and Microsoft's global network, essentially having a dedicated path for that purpose. And that traffic will also still have to go out and reach the internet. This diagram is actually not the best. I'd probably call out that public internet line slightly differently there. But keep in mind that if you do pick the internet route, you also still have to manage either a proxy connection to the internet or a NATed padded connection to the internet for Office 365. And that's for things like DNS, connections to content distribution networks that manage static content for all SharePoint websites. There are a few services that do not operate over ExpressRoute that still require the internet. So if you're connecting via a proxy server, what do we need to think about? So as I mentioned, proxy servers will actually terminate TCP connections and reestablish new ones outbound to the target on the internet. You can do a couple of different things. You can intercept the traffic, make decisions about whether or not you're going to allow it through. And you can potentially inspect it as well and make some more informed decisions. Now, typically when you're actually inspecting traffic, you're actually breaking SSL. In other words, you're allowing the proxy server to sort of impersonate Microsoft services via the certificate configuration on the proxy, and allowing that proxy to effectively become a man in the middle. You're doing a man-in-the-middle attack on all the traffic going out to Office 365. There are products in the proxy or cloud access security broker space that perform sort of a rudimentary DLP type of functionality by doing that. We actually run into a lot of challenges around both performance and functionality with Office 365 if you choose to do that. So we actually pretty strongly recommend that if you're going to use a proxy, that you avoid terminating SSL connections at the proxy and that you're passing things through. You can still make decisions about whether or not to allow or block a particular destination based on things like IP ranges or URLs, but we don't want, we essentially don't want the payload of that network request exposed to the proxy or, even more importantly, manipulated by the proxy. Really important to understand that. So, pros around proxy connections, good things. If you're using proxies today to get to the internet, well, it's going to be really easy to continue to use those proxies for Office 365. Since your desktops, your whatever devices you have on your network internally are already getting out to the internet through a proxy, this is going to be very straightforward to continue to use them for O365. In terms of firewall configuration, typically you already have a process whereby the outbound traffic for those proxies is allowed, so you don't need to think through that anymore. You've likely already got an auditing or monitoring solution set up, but if you don't and you're adding proxies, you now have a choke point where you have some visibility into this traffic, and you can perform those functions. There's also a perception. It's important to use the word perception of a security barrier there between the client and the internet. It's arguable whether or not you're actually going to see a security benefit by routing your traffic through a proxy, as opposed to other types of devices that are going to be less intrusive in terms of the traffic in that path. One of the biggest problems that we have with proxies is that, in general, they manage TCP traffic only. They don't deal with UDP traffic. UDP is really important for Skype, particularly Skype Media. If Skype is unable to make connections over UDP, it will fail over to TCP. But there are performance and, we'll say, end user experience implications of doing so. Skype is not going to perform nearly as well if it cannot utilize that UDP path. And so the Skype team actually has a fairly specific stance on this, which is that all Skype Media traffic should bypass proxies, just period, which I strongly agree with. We see this on a regular basis. So be aware of that. If you have to use proxies, you may, well, if you're going to use Skype, you will almost certainly need to consider ways to allow that Skype media traffic to bypass the proxy. And I'll just leave it there. We have a number of potential performance issues that can come up, primarily because you're adding an additional hop, where that hop can be more or less intrusive in terms of both the time taken to process that traffic, as well as potentially the ways in which that traffic could be manipulated. So we're not huge fans of proxies. I kind of like this graph. This is an example of some testing that was done with a customer that has 5 different locations doing a 30 megabyte file download from Office 365 via proxy connections and via direct connections. Now, you actually can't read the numbers, but you at least have the scale. So in the Houston example here, there's a difference of 89 seconds going through a proxy to download that file versus 15.6. We'll call it 16 seconds in the direct example. Now, this is not due to distance or anything like that. What this is due to is the fact that in all of the cases other than the middle case, the machines that were in the leads office, all the machines in the other 4 locations were directed to a particular proxy or set of proxies that were undersized, extremely overloaded. And as a result, there were these significant delays. In leads, it's actually slightly better download time, which is likely due to the fact that this was just a file download and it had probably been cached in the proxy. It's actually faster to download from the proxy because that particular proxy or set of proxies was not overloaded at the time. But this really is just designed to point out that adding proxies adds additional complexity, additional things to troubleshoot, and additional space for problems to occur. So if a proxy must be used, absolutely make sure that it's scaled properly. One of the biggest discussions that we get into with customers that have proxies is typically around the massive expenditure they're going to have to make to scale up their proxy infrastructure to manage all of these additional connections going through that infrastructure. You think about Outlook and the number of connections that Outlook makes to get to Exchange or to Office 365. It's a lot of potentially long-lived TCP connections that now have to be managed by that proxy. You think about the bandwidth increase of the requests that are going to be going through that proxy as you migrate the services that you're running on premises today to exist within a cloud provider. So scalability is really key there, as well as NAT capability. And what I'm referring to there is simply the number of connections going through that infrastructure is likely to exhaust, well, I'll say likely, is likely to exhaust existing NAT pools associated with that infrastructure. In other words, the number of connections that you can make outbound from a single IP address is limited by the maximum number of port numbers that can be, source port numbers that can be associated with that address. So you typically have to add more public-facing IP addresses to this infrastructure to be able to support that connectivity. Same thing is obviously true in the non-proxy scenario with connections going directly out from NAT devices, but important to remember that it matters here too. And the only other main point that I'll make here again is Skype for Business. You need to figure out a way to move that media traffic such that it's not going through the proxy. So direct connectivity. This is what we think of as a best practice if you can do it. What we're talking about here is, at many of our customers, essentially defining a default route on their network that goes out to the internet. It's not the only way to do it, but it's typically the most straightforward, that takes traffic out through a firewall device or some other type of device that's going to do network address translation and port address translation, such that you can make those outbound connections to Office 365. I did mention earlier that you can block traffic using these types of solutions. It's typically not the same level of granularity that you could perform blocking behavior with a proxy. Usually you're looking at IP ranges that you will allow or deny, similar to what you might do on a firewall. In fact, your firewall may be your NAT and PAT device, depending on what sort of scale you're looking at. But you can do that, and if you have the need to specifically block certain types of traffic or only allow traffic to Office 365, that ability exists. So in terms of the positives here, we don't have the concern about Skype traffic, because you can certainly run UDP traffic out through these devices without issue. In general, you have no ability to do any sort of packet manipulation with these types of devices, so we don't run into those types of problems that I mentioned earlier around proxies with this connectivity model. Additionally, since you're not going through what could be a centralized set of proxy infrastructure, with many of the customers that we talk to that choose to go with this model, you often have regional or potentially per location internet egress. And so you're actually able to do what I was describing around hot potato routing, getting onto our network as close to the physical location as possible, as opposed to the proxy case where you may have a single scaled up set of proxy infrastructure and you end up backhauling traffic from one location to a central location out through a proxy and effectively peering all of your traffic with Microsoft in that central location. Now, if your internet service provider routing is poor, shall we say, I'll use a nice term, this may not always be the best method. But if that's, if we've eliminated that as a potential problem, we think this is almost always the best way to go. So since you are just passing traffic directly, and there will typically be some restrictions on where your users can connect to, you do have to manage those, the IP addresses that can be accessed, or the URLs if your devices have the ability to look at URLs that are being requested. We do publish a list that's updated on a regular basis of all of the IP ranges that are associated with our services. It's a fairly complex list. We publish an RSS feed so you can see updates, and we publish it in an XML file so you can build automation that actually maintains the list within your firewall rules. And there are some partners in the network connectivity space that actually have components within their management tools that will ingest that XML file from us and allow you to automatically consume it for configuration purposes. But important to just keep in mind that that is a constantly changing set of IP addresses, and if you don't stay up to date with it, you're going to experience strange outages. I'll just say that. Hard to troubleshoot outages. So ExpressRoute is a sort of a little bit of a pivot on the direct connectivity method. So it's private peering with the Microsoft network. And it's connectivity both for Azure as well as Office 365 or any other cloud service that's being delivered over the Microsoft network, Microsoft's global network. I mentioned a few minutes ago that not every Office 365 service is exposed over ExpressRoute. And in that list of IP ranges that we have, we actually break things out by service, and we show whether or not a particular IP range is also exposed over ExpressRoute. So you can get a sense it's on support.office.com. If you do a search for IP range list or anything like that, you'll find it very easily. You can get a sense of what is and is not exposed via ExpressRoute. And in a nutshell, it's simply another way to get to the same endpoints that we provide on the internet in a more specific path. In other words, you're still accessing the exact same internet endpoints, the same IP addresses that you will see if you do a DNS lookup for outlook.office365.com and you're connecting over the internet. Those are the exact same IP addresses you're going to connect to if you use ExpressRoute. The only difference is that from a routing perspective, we are pushing down routes into your network that say all of these ranges are Microsoft's global network, and if you see a packet destined for one of those, an IP address within those ranges, send it over this circuit. That's all it is. Think about it as another path to the internet for a very limited portion of the internet. Maybe that's a better way to think about it. So visually, this is how we think about ExpressRoute. And you'll notice that from the customer's network, we have ExpressRoute taking you to Microsoft's global network, and we also have that path out to the public internet, which is also connected to Microsoft's global network. So everything is reachable both from the internet as well as via that ExpressRoute path. ExpressRoute has an SLA, so we certainly do see customers that are interested in using ExpressRoute in order to get that SLA. Important to understand what that SLA means, because there's an SLA for Microsoft's connectivity from the ExpressRoute perspective, and then there's likely a different SLA from your network provider to the point that they peer with Microsoft. So be aware of that. It does provide predictable performance. If you look at ExpressRoute for Azure, as an example, for Azure, what we call Azure Private Peering, which is the way in which you can extend your network infrastructure into Azure network infrastructure and actually see that as sort of one fully connected network, such that virtual machines that you have deployed in Azure are effectively on your network. In that sense, we do talk about the potential for increased performance. And the alternative there is Azure Site-to-Site VPN. You can certainly get better performance over ExpressRoute than Azure Site-to-Site VPN. No question about that. There are also some other advantages that are often touted around ExpressRoute, around security, reliability, these types of things. In general, we associate those much more with that Azure Private Peering, connectivity to virtual machines and other Azure infrastructure, as opposed to Office 365. You can get predictable performance. Now, what I mean by that is the path that your network traffic takes to reach Microsoft's network, because it's not going through the internet, will be more predictable in terms of performance. In a given session with one of our services, your network traffic could be going through, going from Chicago to New York to Florida to San Francisco in one instant, and in the next instant it's going to Canada and Seattle and somewhere else, such that the performance varies from moment to moment, depending on the way the ISP has configured their routing. With ExpressRoute, you don't have that problem. With Skype for Business, you also have the ability to actually maintain QoS tagging, quality of service tagging, into our network, which has lots of potential benefits, particularly if you're thinking about Cloud PBX and actually using Skype for Business hosted in Microsoft data centers for phone calls. Very important in many cases for that. And then we do also run into many customers that have a regulatory requirement around direct connectivity. This is direct connectivity, so this satisfies that. There are a lot of negatives around ExpressRoute, and actually I spend a fair amount of my time these days on phone calls trying to talk customers out of deploying ExpressRoute. ExpressRoute can be extremely complex. It makes it very difficult to troubleshoot problems that occur with Office 365 services to determine whether or not the problem is a networking problem or a problem actually with the a given workload in the service, or with authentication, or with any potential component. Once ExpressRoute is thrown into the mix, problems with ExpressRoute can manifest in so many different ways that it makes solving those escalations very difficult. It doesn't necessarily provide better performance. We certainly see cases where customers have experienced reduced performance with ExpressRoute in the way that their routing has been configured, particularly customers that have multiple physical locations. I'll give you a specific example of that in just a moment. It requires a lot of time to actually get this right. We recommend up to a 6-month planning cycle in order to actually make it work properly. And it's expensive. So there are reasons to do it, but we want to make sure that people go in eyes wide open, understand the pros and cons, and are really doing it for the right reason. And we actually have some limitations now in the deployment process that try and enforce that. You can't actually just today go buy ExpressRoute for Office 365 and turn it on. That option no longer exists. You actually have to go through a review process that makes sure that you're doing it for an acceptable reason. And you typically end up on the phone with me or one of my colleagues to walk through that process before it becomes an option that's actually achievable. So why do we say a 6-month implementation project is required? So we're talking about adding a direct pipe or a direct network path between your network and Microsoft's network. Seems pretty straightforward. And it is for Azure Private Peering. When you're just taking a virtual network that you have in an Azure data center and making that accessible to your on-premises network and your data center. It's really basically one change that you need to be concerned with, and that's with your network edge, and making sure that at that point where you're doing your ExpressRoute peering, that you are accepting the routes that are coming down via ExpressRoute so that your on-premises network understands how to get to that virtual network, and potentially a firewall change there as well to make sure that that traffic is allowed. But that's pretty straightforward, not that big of a deal. Now, when you think about Office 365, you're now talking about a whole bunch of different services that we sell as a suite, Office 365, but are all different in many ways, including connectivity method and the endpoints that you're connecting to and how those are accessed and how clients resolve which endpoint to connect to. You also have to now worry about proxies. You have to worry about firewall configuration in a much more in-depth way than you likely had to with Azure Private Peering. All of these different points add up to additional planning time and additional testing time, additional implementation time. So that's what we're talking about with that implementation project. And it typically involves, for large enterprises, a lot of people. I'm not going to go into all this. You can see all the stuff on the slide, but there are a lot of people and a lot of different potential areas of concern that need to be dealt with. So our guidance for ExpressRoute is that, in general, we think the internet is the right way to get to Office 365. ExpressRoute is an option. And in general, we approve ExpressRoute deployments for Office 365 in a specific set of reasons. A regulatory requirement that says you need to have this direct connectivity method. If it will provide a required benefit for Skype for Business, particularly around media and voice traffic, or if we actually see a real tangible benefit as opposed to all of your other connectivity methods. And as I mentioned, there's a process that we go through that your Microsoft account team manages internally within Microsoft, where a request goes in, we review it, we potentially have some discussions directly with you to make sure that the right things are happening there. But we have a technical block in place where you can no longer go into your Azure configuration and just say, okay, enable Microsoft peering, which is the Azure name for Office 365 ExpressRoute. You actually have to have that Azure subscription ID put on a list that says it's okay, and that's the outcome of the review process. Anybody here still want to deploy ExpressRoute after hearing that? Okay, good. Nobody has to stay after class. You all got the message. Great. All right. So you have multiple options in terms of connectivity to Office 365. From a best practices perspective, we think direct connectivity to the internet from physical locations is really the best choice. Proxies absolutely work, and we certainly accept the fact that that many deployments are going to involve proxy servers because there's legitimate business requirements that will result in proxy servers being in the path. But if you're going to use proxies, the less intrusive you can be with that traffic, the better experience you're going to have with Office 365. So in the connectivity for remote sites, or if you're a distributed organization, any company that has multiple physical sites, there are some things you need to think about in terms of how that traffic gets routed. And latency and availability are the two things that we want to try and optimize for. We want to try and minimize the latency to Office 365 as much as possible, obviously. And we want to make sure that from an availability perspective, you have alternate paths that the traffic can take. We recommend that you spend some time trying to assess this a little bit before you deploy Office 365. Microsoft Premier Services also has something called the Premier Network Assessment. It's an offering for any of you that have Microsoft Premier, a Premier contract, and you have hours you want to burn as you're getting towards the end of the year. It's actually a great way to use up some of those Premier resources without letting them go to waste. It is a very popular offering for Premier, so sometimes there's a little bit of a wait to get one of the engineers to come do it for you, but highly recommended. So take a look at that if you're interested in digging into this a bit more. Let's do a brief example of a customer with multiple sites in the US. So this particular customer has 3 physical locations. They're in San Francisco, Chicago, and New York. You may not be able to read all the things inside the blue dots, but those are actually, well, there are a couple things. In most cases, they're airport codes, but in all cases, they are the internal identifiers that we use for labeling our network equipment. So when you do a trace route, those are typically the things that you would see associated with router names as you're looking at those different hops in the path. So over here, the customer in San Francisco is close to the SFO node, et cetera. The red line indicates the customer's managed network. In this case, we'll just say it's an MPLS network. They have connectivity for all of their offices. Those of you who are not asleep will notice that there's a missing line to the Chicago office. That is unintentional. I just noticed that, sorry. But just assume there's another red dotted line between the customer's managed network and their Chicago location. The yellow lines, hopefully none of you are colorblind. I'm sure that's the case. I'll highlight them for you because that's a bad assumption. So there's a line here in San Francisco, a line here in Chicago, and a line here in New York as well. Those represent internet connectivity. So these customers have internet egress at each one of their physical locations. So this is actually great. This customer has followed our recommendations very nicely. They have internet egress that's physically close to each one of their offices, and they're using that to get to Office 365. For the purposes of this conversation, we'll say that this customer is using Exchange Online, and all of their mailboxes are currently somewhere close to Des Moines, Iowa. We actually happen to have a data center in Des Moines, Iowa, so it could actually be at that same location where we do network peering in Des Moines. So they're going to, let's say we have a user in New York. They're going to jump out to the internet from that location in New York. We're going to assume that they have good ISP peering into Microsoft's network. So they're likely going to have a couple milliseconds to make that hop through their ISP network into Microsoft's network at our location physically in New York. And then they're going to traverse Microsoft's network to get to Des Moines and access their data. That should be a very nice route for them. Now, let's say this customer says, oh, I want ExpressRoute, because ExpressRoute is the best. It has the word express in it, therefore it's faster. You laugh, I hear this often. We're very good at marketing things. It's a good name for it. Unfortunately, it's not always true. So we're going to deploy ExpressRoute with a single circuit in Chicago, because we're cheap. But it's going to make things faster because it has Express in the name. So this new wide green line here in Chicago is going to be an ExpressRoute connection that peers in our Chicago location. Fantastic for users that are in Chicago. But what this now means is that the customer has a choice about how they're going to route traffic. They're either going to continue with the regional internet egress for users in New York and San Francisco, or they're going to backhaul their traffic across their own internal managed network, potentially an MPLS network, and egress out through their Chicago office via that ExpressRoute circuit and onto Microsoft's network. Well, it's probably not that big of a deal if they chose to backhaul their traffic across their MPLS network, assuming that they had the bandwidth to do that. Not always true, but assuming that they have the bandwidth to do that, because they're accessing their data in Iowa. And when you think about where these locations are relative, that's not too bad. That's a relatively direct path. But what happens if we change the equation a little bit? And we also magically add in that red line that should have been in there previously. Now we move their mailboxes. The mailboxes are now active in our Columbia data center in Eastern Washington. And these users in San Francisco, because the customer decided to backhaul their traffic, is now accessing their mailboxes by jumping onto their MPLS network or their managed network, heading over here to Chicago, jumping onto ExpressRoute, not so express now, peering with Microsoft's network in Chicago, and then coming back up here to Eastern Washington. Not optimal. Now, having said that, this is the US. Those latencies are probably still pretty low. So, if there was a good business requirement to do this, it might be okay. You'd have to evaluate that, do some trace routes, and make sure that those latencies were all okay, but certainly not optimal, right? So what can we do? Well, we could be less cheap and deploy another ExpressRoute circuit here in San Francisco. Now my San Francisco users have the ability to egress to ExpressRoute in San Francisco and jump up there quickly. That helps. Doesn't make much of a difference for New York. But hypothetically, this customer has their data in 4 locations, one of which could be down here in Virginia. There are multiple potential locations on the East Coast where that data could suddenly become active. So now we're talking about another ExpressRoute connection in New York, et cetera. Key point there is that there is no one-size-fits-all answer. You need to actually model connectivity, figure out what the best choices are given physically where you are, what your ISP routing looks like. If you're going to use ExpressRoute, figuring out where those egress points are is really critical, and balancing the potential cost of those versus using internet access is certainly going to be key. So let's briefly talk about latency and bandwidth, and then hopefully we'll have time for a few questions. So when we think about latency, the thing you need to be aware of is where you're connecting to, obviously. I'm going to be connecting from my laptop to my mailbox somewhere. I need to figure out where that somewhere is. Now, this is challenging challenging in different ways depending on which workload we're talking about. So with SharePoint today, there's a big asterisk beside this, it's fairly straightforward. If I do a trace route to tenantname.sharepoint.com, in my case it's mulif.sharepoint.com, because that's the name of my Office 365 tenant, that's actually going to take me to the data center that's hosting SharePoint for me right now. Not so easy with Exchange Online. With Exchange Online, your clients connect to outlook.office365.com. Has anybody ever actually done a DNS resolution of that name? That's useful. So we get a bunch of IPv6 addresses, a bunch of IPv4 addresses associated with that. What that is the result of a GeoDNS query done by our infrastructure based on the originating IP address of the DNS query. So we looked at the fact that I did a DNS query from Chicago. And we made a decision based on that. And that decision was for those of you that understand Exchange, which CAS servers, which will be the first hop of that connectivity, we're going to direct that traffic to. And that decision is made for a couple of reasons. One of them is latency, the other is availability. So some of these are very close to me, some of these are not very close to me, in case there's a natural disaster and I need to fail over to some other servers, or in case there's some sort of software issue in that data center, or we lose power in a data center, whatever the issue is. These are all in different locations. Additionally, you have no idea which locations they are. If you try and do a reverse DNS lookup on those, you're not going to get an answer. So you can't really do much with that. What we recommend is to use the SharePoint result as your best option. There really is no good way for you today to run a trace route and say, okay, this trace route is from my machine to wherever my data is in Exchange Online. It doesn't exist. So just be aware of that. From a Skype perspective, it's also different. So Skype actually has something called the Skype Operations Framework, not the Skype for Business framework. The Skype Operations Framework that I believe there's some sessions at this event talking specifically about it. Part of that includes some details about their internal deployment, the media relay components that are used as that first hop. And they also have some tools that are part of that framework that allow you to actually estimate your latency between your internal network environment and Skype for Business. Use those tools in order to figure out what that latency looks like for Skype. Traceroute is not the right tool for that. The big asterisk around SharePoint is that we're also in the process of making some changes in SharePoint to try and minimize latency issues. And so that's going to result in your first hop for some of your SharePoint traffic not necessarily being to the data center where your SharePoint data is. So at the moment, tenantname.sharepoint.com with traceroute is a great way to go. It may or will change at some point in the future, and we'll have to figure out, we'll have to publish some new best practices on how to do this. But for the moment, tenantname.sharepoint.com is the way to go. Important to be aware that there are multiple factors in latency. There's desktop machine to the customer egress, essentially the point that you manage. There's the part that the ISP manages, where you connect to your ISP and where your ISP peers with Microsoft. And then there's the part that we manage within our network. So I'm not going to go into much detail here other than to say, in terms of customer to egress, one really important thing to be aware of is proxies. So obviously, if I wanted to do a trace route and all my connectivity is going through a proxy, I'm not going to be able to do that trace route. Proxies don't typically manage ICMP traffic. So I'm going to have to actually run a ping test to figure out latency between my desktops and my proxy, and then do the same thing between my proxy and the target, and add up those different components. Also important to be aware that, I mentioned that ExpressRoute is not always Express. As you think about all these different paths that traffic's taking, this is actually just a different way of looking at one of the problems that I was describing with that customer scenario with the 3 sites. So at site A, I have 10 milliseconds out to my proxy server, and I jump onto the internet, and the latency between my egress from site A to Microsoft's network is 30 milliseconds. So, desktop to Microsoft's network, 40 milliseconds, not bad. Customer site B, I've got my ExpressRoute peering. Now, if I wanted to use that for my Office 365 connectivity, I've got 40 millisecond latency between site A and site B. My ExpressRoute latency is 20 milliseconds. It's less than that internet latency, which is frequently true. I would expect that to be normally true. But because I'm now backhauling traffic between site A and site B, my actual latency to get to Microsoft's global network is now higher. I'm looking at 60 milliseconds there versus 40 milliseconds. In that particular example, that latency difference may not matter. But if you are in an area where those numbers are larger and the difference is larger, then things start to get really interesting quickly. So what's a good latency number? In North America, we shouldn't really be looking at latencies, total end-to-end latencies of anything more than like 100 or 150 milliseconds. You'll see that that number is higher than the number that we claim for EMEA, Europe, Middle East, and Africa. I would argue that in general, that's because the vast majority of those customers that we work with are in Europe, and Europe is physically much smaller, and so latencies there are typically smaller. You're not looking at potential cross-continent links that we see here in North America. One other point there, for Skype, it is possible to deal with latency up to 400 milliseconds. I would hope that, given where you're located, that you're not going to be seeing those, but it can be managed. 350 milliseconds tends to be where we start calling out problems. And if you are a customer that's using Exchange in online mode, we typically see this if you're doing VDI desktops. You typically need to have less than 100 millisecond latency between that VDI infrastructure and Exchange Online. Otherwise, activity in Outlook starts to get very painful. In terms of actually measuring this with ping, you generally cannot ping services directly in Office 365. We block ICMP at various points. There's a tool called PSPing. It's a sysinternals tool you can find very easily on the internet that actually performs a ping using a TCP session. So you can tell it, use port 443, the HTTPS port, to perform the action. And that'll get through all the way to an Exchange CAS server or to SharePoint or whatever infrastructure you're trying to ping. Makes it much easier to do, or possible to do. From a bandwidth perspective, I mentioned bandwidth planning is important. We do have bandwidth calculators that are available for Outlook and Skype for Business. Those are fantastic if you actually have the right inputs, right? Anytime we calculate something, particularly when there's a lot of big numbers involved, the results are gonna vary pretty dramatically. The better the input, obviously, the better the output. So we recommend, in general, using this approach to estimate bandwidth. Take a look at what you're currently using for Exchange bandwidth today. You can go look at network counters and perfmon on your Exchange servers. It's fairly straightforward to do that. Monitor over a week so you can look at peaks and use that as an input from a sizing perspective. Consider the impact of SMTP traffic. Obviously, the way you're going to route SMTP, whether your inbound traffic from the internet is going to go directly to Office 365 or whether it's going to come to your on-premises system first and then get routed up, those types of choices will have an impact on what your internet bandwidth, how your internet bandwidth will change as you move users. If you have SharePoint deployed today on premises, same thing. You can take a look at your bandwidth utilization with network counters in perfmon on those servers. With OneDrive for Business and Skype for Business Online, you have some control here, and you also have a calculator for Skype for Business that'll help you figure this out. With OneDrive for Business, you have the ability with group policies to actually put some throttling into place, essentially, for that initial upload where we typically see bandwidth problems in this space. And then round up. When you're planning for bandwidth, always round up. You always will end up consuming more than you need today. So having that extra is a good way to go. I don't like showing the MSIT number. Microsoft is not like any other customer that I've ever met. So trying to compare yourselves to what we use is, I mean, you'll either be above this or below it, or the same. So not much value in showing that number, but there it is. The other way to deal with this is to do a pilot, obviously. And that is, move some users to Office 365, see what that impact is. You have to be careful how you pick these users. They need to be a good cross-section of your user population, and figure out exactly what the impact is of moving those users, and then extrapolate linearly based on those numbers. We actually have a whole bunch of content that we have done typically at the Ignite conference around troubleshooting. And this is a conglomeration of topics that we go into in detail there. If you're interested, go to ignite.microsoft.com, do a search for network troubleshooting. And I believe there's a session by Paul Collinge, who's one of my co-workers. He goes into great detail on all of these topics that are listed here and how these can influence Office 365 performance. I'm not going to go into specifics on all of these, other than to say that the two that you really need to spend a little bit of time thinking about and making sure you get right are TCP window scaling and DNS lookups. Because of the way for Exchange Online that we do GeoDNS lookups to decide where to send your traffic, it tends to be less of an issue in North America than elsewhere in the world, but important nonetheless here. If you are doing DNS resolution in locations that are not the same as where your internet egress points are, you can end up getting sent to Exchange servers that are very different from where you would expect them to be sent. As an example, I don't know why you would do this, but if your desktop machines were in some way pointed at DNS infrastructure that was in Japan, that means that when your users do a query for outlook.office365.com, we will see that query come from Japan, and we will send your users to CAS servers in Japan. Happy to do that, because we think that that's the right thing to do to ensure that you have the best performance. So you can see problems because of that. TCP window scaling is another area, particularly around SharePoint, where you can run into issues. It refers to the ability of the network stack in Windows or any other operating system to change the amount of data that can be sent in a TCP transaction, essentially, without having to receive acknowledgement from the server before it'll continue on. And that means that the scalability of that session, or the amount of bandwidth that can be consumed, as latency increases, the amount of bandwidth that can be consumed decreases. So if you're accessing a SharePoint site that's on the other side of the world, so latency is high, if TCP window scaling is not configured properly on your desktop machine as well as all the infrastructure components in the path, you can actually end up having very bad performance as opposed to enabling TCP window scaling and seeing like a 60x increase in performance potentially. So something to look at there. Other than that, aka.ms/tune has some great resources. So you're going to get this slide deck. There is a set of links at the end that includes some of the recorded sessions that I mentioned, some of the guidance pieces that I mentioned, further details on ExpressRoute, lots of things for you to read. If you need help going to sleep, take a look at some of these materials. No, I shouldn't say that. Some of the recordings are actually great. And with that, hopefully all of you are about to get up and walk out of here with me and let me buy you a tasty beverage in Hall D1. If you don't have an opportunity to ask me a question, either here while I'm packing up, Hall D1 at the Ask the Experts, feel free to reach out. There's my email address and my Twitter handle. I'm happy to engage where I can. Just be aware that I can't personally replace Microsoft support, so there are occasionally things that I have to say, sorry, call support, but in general, I will be as helpful as I possibly can. So thank you for coming and staying until the end.